Hi dears, welcome to my channel. Today I am here with class 8 lesson 4, that is combustion and flame. What was the third lesson? It was coal and petroleum. Do you remember? By the time I have asked you 3 questions, it's the time to answer these questions. See, first question was naphthalene balls are obtained from dash. Answer is coal tar. Second question is when we are heating in air, the coal burns to produce dash gas. When the coal is heated, we will get dash gas. Carbon dioxide is the answer. Okay, the third one is forest and coal are dash natural resources. Forest as well as coal are dash natural resources. The answer is exhaustible natural resources. Okay, we are back to the class. We are done with combustion and flame. What is this combustion? Dears, we are going to see about combustion and flame. It is a continuation of the third lesson. You may feel how it is the continuation. The reason is, in the third lesson we have learned coal and petroleum, right? These coal and petroleum are what? They are fuels. Fuels, with the help of fuel only, this combustion is happening. So, it is the continuation. This lesson is the continuation of the third lesson. Okay, ma? Now, for the combustion, what we are saying, the fuel is needed. Okay, magnesium, in the 7th standard itself we have learned magnesium ribbon when heated, when it is shown in the flame, what happened? It burned with producing white ash. Do you remember? Magnesium, there I have told you the formula also. Mg plus O2 gives MgO. 2 Mg plus O2 gives 2 MgO. Magnesium, how it is combining with oxygen? How do you feel? Actually, when it is heated, atmosphere will be containing what? Oxygen. With this oxygen, magnesium is combining, and with this, what happened? It is burning, and we are getting magnesium oxide. Which means, when anything is burning, what will happen? It reacts with oxygen. Okay? When anything is burning, actually it is reacting with oxygen. So, what is this combustion? What is the first one? The name is combustion. So, what is this combustion? It is a chemical reaction in which a substance reacts with oxygen to form heat. Sometimes light also will be formed. Again, I will say combustion is a chemical reaction in which a substance reacts with oxygen to produce heat. Sometimes light also, all these. This is combustion. The substances which undergo this combustion are called what, ma? Combustible substance. Now tell me, what are the combustible substance? Give example. Can you give some examples? Yes, kerosene. Then your petrol, coal. All this we have learned. All these things are combustible substance. Okay. With this combustion is happening. Okay. Now we understood what all things. Substance is needed. Combustible substance is needed for this burning or firing. All these things will be needed. For this combustion, this combustible substance is needed. Is it enough? No. As I told you, oxygen is also essential. Because oxygen means air should be there. Air contains oxygen, ma. So it will suck oxygen from the air, and with that combustion is happening. Okay. Combustible substance, oxygen. These two are only essential things for combustion? No. There is one more important thing, that is ignition temperature. What is this ignition temperature? Temperature, minimum temperature at which the substances start burning is called the ignition temperature. It will be differ for different substances. Kerosene, when the kerosene is shone to the flame, it will catch fire quickly. When wood, okay, log of wood, a dry wood is shone to the fire, it will take some time for this log of wood to catch fire. If you are showing this, not the dry, when you are showing the raw wood, when if it is not dry, it will take much more time to catch fire. So this ignition temperature differs. Okay, ignition temperature is the lowest temperature from which this flame or combustion will be starting. Below this temperature, what happens? Combustion will not start. Is there any doubt in you? Yes. Means if your mother is cooking all the time, she will be always in kitchen, right? She will be cooking for you. Amma, vada I need. Amma, I need a porota. I need something. All you will say. Okay, especially during vacation time, right? So by the time when she is in making vada, what will happen? She will take this kadai in, and she will pour oil in it, and she will see whether the oil is heated or not. When the oil is heated, some kind of flames will, some kind of this gas or she will be able to understand that by the smell itself. She will be able to understand that the oil is heated. Then only she will put this vada or whatever you want. She will put. Okay. So if she is letting it for a long time, what will happen? She will not do that. I know, but still I am saying, if the oil is letting it to burn, to the flame, what will happen? After some times, above the oil, it will catch fire. It will be firing. Okay. So why is it so? Because temperature will be increased in the oil, and at a particular stage, it will reach the ignition temperature and the oil catch fires. Okay, that's why she is not allowing you to the kitchen. Main because of this reason. You don't know all these things. Now only we are learning, right? So that's why I am saying the ignition temperature, when it is reached, what will happen? The substances catch firing, or it will become combustible. It will be able to go this combustion. Combustion will be happening to these substances. So for oil, the combustion time is much more compared to this kerosene. When kerosene is exposed, and if some flame is gone, what will happen? It will catch fire quickly. Camphor, puja, for the puja, camphor will be taken. No, when camphor is shown in the fire, what will happen? Quickly it will burn, isn't it? So this ignition temperature are differ from different substances. Okay, so these things are needed for this combustion and all. So we should know one more thing. What is that? What are inflammable substances? Substances which catch fire quickly are called inflammable. Substances which catch fire quickly. For example, when you are switching on the gas and we are lighting it, quickly it will burn, isn't it? Like that, again I am saying camphor. When it is shown to fire, quickly it will burn. So they are called as inflammable. Quickly they will get flame. They are called inflammable substances. Now, we should know sometimes something had happened. Means firing has been happened. We should know how to control it, isn't it? Okay. For example, if you are taking this paper, our marks, science, you are getting good marks. If you are not getting good marks, something may have happened, right? So by the time if the paper has been fired, okay, or something the paper has been fired, what will happen? You will take some water and you will put it off, isn't it? So if we are applying water, what will happen? This paper or some these substances will be the fire will be put off, isn't it, ma'am? Or your clothes, if it has been catch fire, quickly if you are pouring water over it, what will happen? We will be able to keep the fire down or put the fire down. Why is it so? What is the specialty of this water? We are now thinking, why? Have you ever thought why water is able to put out fire? Because it lowers this ignition temperature. As I told you, when the ignition temperature is reached, then only firing will be happen. If we are putting the water over it, it cools down the temperature. So what will happen? Firing will not happen. See, ma? See, these three things are needed. First is heat, second is air, third is fuel. Any of these has been removed, this fire can be put in control. Okay. Second thing, if we are moving to see, when oil get fired, what will happen? Oil get fired, if you are applying water again above it, the fire will not come to stop, because oil is lighter than water, so that when the water is applying, water will be settled down and the oil will be in the top. So what will happen? No problem, no reaction, the oil will be keep on firing. So is there any other way? What is a fire extinguisher? Fire extinguisher other than water is carbon dioxide. It will be seen in banks, in offices, in some other, to say apartments, all these, the fire extinguisher will be present. That is, the carbon dioxide will be present in the form of cylinders and will be hanging in the walls, right? Have you seen it? They are called in buildings. All these it will be seen. So they are these fire extinguishers. What they are doing is, when we are applying this, the carbon dioxide will be spread. Then what happens? This carbon dioxide will be spread in such a form that it will takes away the contact of this fire with air. Did you get ma? It will be act as a blanket. This carbon dioxide will spread a lot, and if they are lighter than this oil and all, so what will happen? It will be spread above this fire, and it will cut the connection of this fire with air. So what happens? Is it possible for the fire to move more? No, because only when the oxygen is there, what will happen? The firing will be happening. If the carbon dioxide is there present as a blanket, it will not be in contact with oxygen, so this firing will be stopped. Okay. And the third one is fuel. The fuel is removed, then the firing will be always stopped, isn't it so? So these things, what are the three things which makes you to firing is heat, air, fuel. If it is difficult for you to remember, I will give you a help. That is hand, arm, finger. Okay, hand is there, no? Arm is there, arm is there, hand is there, finger is there. Arm, hand, finger. Easy for you, or hand, arm, finger. Arm, hand, finger. Like that, it will be easy for you to understand. So, heat, air, fuel are the three things which causes this firing. So, any of these has been cut, what will happen? This firing will not cause. For example, the heat can be lowered. This ignition temperature can be lowered by adding what, ma? By adding water. The conduction of the air can be reduced by adding what, ma? By applying carbon dioxide. And if the fuel is removed, what will happen? No firing. These three things, this is very important here. They will ask in many ways, and this is the only solution for you. Arm, hand, finger. This air, heat and fuel are the three things needed. And if any is removed, let's stop. Now we are moving for the type of combustion. What are the different types of combustion? Combustion can be of different types. First is a rapid combustion. For this rapid combustion, it needs fire. A kind of firing is needed. For example, I am saying LPG, when the gas stove, when we are igniting it, what will happen? It will catch fire quickly, isn't it, ma? But it needs something to put on the fire. Okay, so when we are giving a little fire to it, it will start burning and it will be continuing. It is called rapid combustion. Okay, then the second is spontaneous combustion. In the case of the spontaneous combustion, no need of fire is needed. No need of fire. When it is kept open, it will start firing. Quickly it will start firing. That is spontaneous. For example, phosphorus, white phosphorus. When it is kept open, what will happen? It will start firing. Because it will directly in the contact with the air, oxygen, and it will be directly catches fire. And in forest also, when the dry leaves are there or dry wood is there, when they are just touched to each other, what will happen? Fire will come and it will be fully burned off, isn't it? It is the example of spontaneous fire. For knowing the things, you first remember the example, and from that you will be able to learn it quickly. Okay, ma'am? Then the third is explosion. Explosion. When we are saying this explosion, what is coming in your mind? Crackers, isn't it, ma? When we are giving a little fire, full explosion, isn't it? Shivakashi and all, if they are the cracker, much more companies are there. These people used to suffer a lot because of this explosion. If a little fire or unknowingly, if any fire piece has been there, fully the building will be fully exploded, and it has been happened many years. And I'm saying this explosion is very dangerous now. Explosion along with heat, much more heat, light and sound also will be coming in the case of explosion. This cracker is the best example for this explosion. Okay, now we are moving to see what will happen to the matchbox. And what is the mystery behind this matchbox? Okay, why it is so? Because it is there in your textbook, but not much more explained. It is if you are knowing it much more, it will be easy for you when you are moving for higher classes. So matchbox, when we are just touching the matchstick over the matchbox, what will happen? Fire is coming. How is it happening? The thing is the matchbox, no? This matchbox containing red phosphorus and some glass powdered glass. Okay, and the matchstick containing oxidizing agents. Okay, when we are rubbing it, what will happen? Friction is coming. You have learned about friction, right? Friction is coming. So what will happen? This red phosphorus in the matchbox, now it will be directly convert into white phosphorus because of the heat. What will happen to the white phosphorus? I have already told you. When the white phosphorus is just touching with this oxidizing agent, it will catch fire. This is why the matchbox is quickly catching fire. If the matchbox is dipped in water, will it catch fire, ma? Why? Because ignition temperature has not been reached. See, Kanna, if you are knowing the things quickly, you can able to ask much questions and you can able to solve these questions. That's the fun of science. Okay, learn science, go along with science. If you want, I will be helping you. Hi dears, welcome back. Today, what all things we have discussed here? We have discussed many things, and in it, we have to see what will happen to a person if his clothes caught fire. If the water is not available by the time, if it is in this situation, if the cloth, any of the piece of the cloth is started firing, what we have to do? If any blanket is there nearby, you have to wrap that person with the blanket. Where it should be thick, Kana. It should be thick. The thick blanket, if you are having, you can wrap the person immediately with this blanket. So what will happen? The fire will not be the fire will be out of touch with air. So what will happen? The blanket will protect for the person from firing. So the fire will not be caught more. Okay, ma. This is the same function which the carbon dioxide is doing. This is if anyone is asking, in such a manner you have to write. If water is not there and if the clothes started firing, what will the thing which you can do to protect the person from firing? It is the best answer for that. Okay, now we are moving for flame. What is flame? Flame means you can see flame, no? If you are catching a matchstick, if we are brushing it, if the matchstick is kicking on the matchbox, we can see the flame. So, what all the things are there in a flame? You can see this flame, it is having different parts. On the yellow part, you can see, right, ma? Below it, the part is not that much yellow, a light tinge of black color is seen, and above it a light, small light can be seen on the top. So we can divide the flame in three parts. That are three zones we are saying. They are non-luminous zone, luminous zone and dark zone. The zone which is in the top is called non-luminous zone. It will be maximum blue in color. Once again, you can see it. Yellow part can be seen. Above it, a blue color tinge can be seen. It is called the non-luminous zone, and this zone will be having maximum heat. And the second yellowish part is called what, ma? It is the luminous zone, and the dark color, it is seen in the black or dark blue color, can be seen below it. It is called the dark zone. From the dark zone, it shows that the substance is getting vaporized in that zone. So it will not be having that much hotness. Then the luminous zone will be above it, and it will be having a little heat compared to the dark zone. But in that part, we can see what the carbon, the unburned carbon can be seen. And above it, a blue color tinge can be seen. That is the zone which will give you maximum heat. So, in general, we can say if the fire is burning in blue color, the fire will be burnt with no carbon residue. Means combustion is complete if the fire is burning in blue color. If the fire is burning in yellow color, it means the fire is burning with inappropriate combustion. Means combustion is not fully done. Means some ashes or remains of carbon will be present in that flame. Okay, so how we can distinguish is, if we are taking a pot or any vessel, and if you are keeping it above the gas, what is the color of the gas stove, that flame? It is blue in color, right? And if we are cooking, after that, when you have cooked completely, and take that pot and just touch after it is cooled, you cannot see any blackish mark in the base of it, which means that combustion is complete. There is no carbon residue for the flame. Okay, if we are cooking with the wood is burning in yellow color, that pot or the vessel will be fully black at the base. Have you seen? Your mother, you may in the olden times only wood is there. By the time gas has not been come, by the time all the vessel base will be black in color, which means the carbon residue can be seen. The burning is not complete. It is called incomplete combustion. Yellow color flame means incomplete combustion will be there. Okay, dears. Why this is the way we have to say. See, can you see the candle? Non-luminous part is the topmost part, which will be blue in color, and the luminous part yellow in color, and the base part is dark zone. Okay, these three zones can be seen on the flame. Now we are moving for fuel. What is fuel? We know that in for the fire there are three things needed: hand, arm, then what? Finger. Like that. Heat, air, and fuel. The fuel is the most important thing which is needed for firing. Fuel is the substance which helps to give you heat, or with the substance, they are the source from which we can generate heat. It is called what, ma'am? It is called fuel. Everyone want to have the fuel. It should be cheap for us. Okay, it should combust completely, means there should not be a carbon residue or nothing should be there. And the third point is, it should give more heat. Okay, and fourth point is, it should be readily available. This kind of fuel we can obtain only in dreams, because if the fuel is cheaper, it will not combust completely. If the fuel is combusting completely, it will be costly. In that manner, we are moving. Now we are moving for fuel efficiency. Means to which extent the fuel is efficient. For that, we have to see the calorific value. What is that, ma'am? Calorific value. What is this calorific value? Amount of heat energy produced by burning 1 kilogram of fuel is called the calorific value. How much heat energy it is generating if it is burned, for 1 kilogram of the fuel is burned. Okay, ma'am? It is the calorific value. Burning, no, we can say on the complete combustion. It is the specific word you have to use. Amount of heat energy produced by the complete combustion of 1 kilogram of fuel is called what, ma'am? Calorific value. By that we are checking whether it is having high calorific value. This thing is having high calorific value. We are comparing it with various fuels. Okay, ma'am? So it is having a unit, ma'am, that is kilojoule per kilogram is the unit. Kilojoule per kilogram. Okay, ma'am? Because heat energy related joule, and 1 kilogram, so kilogram. This is about the calorific value. So various fuels, for example, cow dung. Cow dung, when it is heated, means when it is kept in sunshine, it will be able to get heated quickly. Okay, ma. So it is also it is the cheapest fuel available. But is it having higher calorific value? If it is having higher calorific value, the cows will be so special, right? Not only for the milk, for the cow dung, they will use this cows much more. But it is having very less calorific value, Ganna. It's about 5,000 to 8,000 only. Compared to that, if we are comparing it with LPG or CNG, it is 50,000. Calorific value is very high. For hydrogen, if it is burning 150,000. All this, so calorific value differs on different fuel. Okay, ma. Now we have told about the fuel. If the fuel is not there, what will means? What does if the fuel is not there? What all things may happen? Means to which extent the fuel is needed for us. All this we have said. Now we are moving to see the bad effects of fuel. Is there any bad effect for fuel? Yes, much more bad effects are there. As I told you, the things which are made of carbon, all the things which will liberate this carbon, which will cause respiratory problem. Okay, if the smoke is there or if anything is burning, what will happen? The smoke will be coming up, right? Smoke will be coming up. What will happen if you are moving near it? You do like this. Oh, what an irritation it is. Oh, some children start coughing even, isn't it? So which means it will cause respiratory problem. This carbon will stuck on your nose, your mouth, your eyes even. Drops of eyes will drops of tears will come, or you may have respiratory problem. All these because of this. This is the bad effect of fuel. And the second thing, if it is burning smoke, I told you. The second thing is carbon dioxide is liberated. If the something is burning, carbon dioxide is liberated much more. If the carbon dioxide is more, what will happen? Global warming will be caused. What is this global warming? All the time the teachers are saying about global warming. We have no idea about global warming. Like that anyone is having? Nothing dears. When carbon dioxide is much more in atmosphere, it will produce heat more. It will generate heat, more heat, or temperature will be increased. Normal temperature of the earth will not be maintained and the temperature will be a little raised. So what will happen? Globally, it starts warming. That's global warming. Globally, as a globe, the earth started warming. So what will happen? One of the bad effects is in Antarctica and the places which are so cool and the ice are there in this region. When it started heating, globally if it is heating, the ice will start melting. So what will happen? The earth itself will be in suffocation. Any problem will be there? No, the earth's atmosphere entirely will be changed. This is the global warming, and because of the carbon dioxide increasing amount, global warming will happen. By burning the fuel, the carbon dioxide level can be increased. So it is a bad effect. The third one is incomplete combustion. If the burning is with incomplete combustion, what will happen? Carbon monoxide is produced. Carbon monoxide is such a poisonous substance. If it is liberated, it will affect human as well as other animals and all other creatures. Carbon monoxide is a toxic substance. It should not be liberated in the atmosphere. And the fourth one is when we are allowing the things to burn much more, it will create sulfur dioxide or nitrogen dioxide, which will mix in with the clouds and which results in the acid rain. Acid rain, as you know, when it is affecting the plants, what will happen? When the acid rain is falling on the plants will be dead even. Okay, so not only for plants, animals, it will also affect. All these things will be caused because of this unnecessary burnings of fuel. See, Kanna, the candle is burning, ma. The candle is burning by taking oxygen from the atmosphere. It is burning in constant way. Now I am closing it with a glass. You can see now also the candle, isn't it, ma? It is burning, but now slowly it is stopping. The flame has gone. Do you know why? What is the reason behind it? The oxygen is not available now. When we are closing with the glass, the air inside the glass will be having some oxygen. With that oxygen, the candle was going on flaming, but that oxygen also has come to an end by the time it stopped. Okay, ma? This is one experiment. Now, again, I am burning a candle. Help to tell you what is flame. See, ma, I am burning the candle, or here itself you can see it is burning. Now I am taking one mosquito coil. Mosquito coil, see, ma, the fire has been stopped by itself, and it is also, we can see that here the flame is coming because the substance get evaporated, that is the wax get evaporated, it is getting vaporized with heat, and which gives you flame. But what happened to it? Here it is also burning, but the flame is not coming. We can't say that it is not burning because the flame is not there, but still it is burning. See, the smoke is coming. This here there is no vapor. The substance is not getting vaporized. That's why flame is not coming in the case of mosquito coil. But here the substance is get vaporized, which results in formation of the flame. Again, one more experiment is when we are lighting a matchstick and we are putting it in water, it's come to an end. What is the reason behind it? Because of the ignition temperature has been stopped when we are cooling it directly by putting in water. That's why this is one of the way for putting off fire. Thank you, dears. That's question time. First question is fuel to be heated to its dash for burning. Fuel to be heated till it reaches somewhere. Some temperature it has to reach for burning. What is that? Okay, ma? Second one is fire produced by oil is controlled by dash. Fire is produced when fire is formed in an oil. It can be controlled by applying dash. Third question, incomplete combustion of a fuel gives dash gas to atmosphere. Incomplete combustion of the fuel gives dash gas to the atmosphere. Thanks for watching.